through how to do have a virtual lab that you're going to complete. So I want to walk you through how to complete this and what it all means. So this week, the focus is the difference between balanced and unbalanced forces. So with balanced forces, when the forces are the same on both sides, there's going to be no change in movement, the object will stay at rest, and the net force is going to be 0. If it's an unbalanced force, that means that one side has a stronger force applied. And there is going to be movement, it is acceleration, and it's going to have the net force. So you're going to need to do some math to try to figure out which side is stronger and how it's going to move. So let's walk through the lab. So first of all, it's a pHet lab, which we've done in class before. The last one we did was light and color. I'm going to click that to open that up. And we're going to do this one right here, net force. And you're also going to want to open up the document, which is the lab report. You want to save it somewhere and open it up as you download it. And now you'll be able to type on it. So let's go ahead, and what I want you to do is have both screens open at the same time. You can do this by minimizing right up here in this corner. And then you can pull the documents side by side. You can even make this document a little larger so you can see it a little bit better. Okay, so this is the directions up here. But basically, you're going to have your lab open. The first thing it says is enable the measurement functions by checking the box in the top corner. So we want to check all of these boxes right here so that we can see all of the different measurements that are there. Then we're going to go ahead and we're going to start the lab. It says explore the program by placing the red and blue figures on the rope to simulate a tug of war. Which figure can pull with the most force? So let's see, let's try this guy here. Let's move him over a little bit. There we go. So you can see this guy, the blue guy, the largest blue guy, can pull towards himself, because this is tug of war, with a force of 150 newtons. So let's check the next size. 100. The little guy, he can pull 50. So it says which figure can pull with the most force? Well, it's going to be the largest person. He has the most mass, so he can pull and have the most strength. You probably have played tug of war before, and you really want people on your team that are strong and big because they can pull with more force. So the next thing, so we would just write in here, the largest man. It asks the exact measurements for each one. Well, this one, the large man, we just figured out is 150 newtons. We looked at this just a second ago, but we can pull up the medium-sized guy. Just type that in, is 100 N, or newtons. And the smallest guy is going to be 50 newtons. Okay, so step 2, it says place 2 figures on the left. So we're going to take the 2 smallest guys. And 1 medium red figure on the right. Okay, notice the forces. If we hit go, how's the movement? It's not moving. If you look at the left, the 2 smallest guys are pulling with 100 newtons. So it says, what is the resulting motion or speed? No movement. And what is the sum? Well, if this guy is going this way with 100 and this is 100, we really need to subtract those 2 numbers because they're going against each other. And 100 minus 100 is 0 newtons. So if we wrote this, it says use a math equation to show how the net force was calculated. We took 100 newtons minus 100 newtons equals 0 newtons. They're working against each other. Are the forces balanced or unbalanced, and how do you know? So you have to think back to all the things we learned this week with balanced and unbalanced. Well, they're not moving, and they're the same. So it is balanced, and because it is balanced, there's no movement. Are you starting to get this? It's a little bit of sort of common sense. All right, so step 3, place 2 small blue figures on the left. Let's return it so it goes back to the normal. To the left against 1 large red. Okay. Do you want to predict what's going to happen? Think about what you know. Have you made your prediction? Let's test it out and see if you were right. Who's winning this tug of war? Not much of a match, is it? So what is the resulting motion or speed? Well, it's moving to the right. The red man is winning. So what is the sum of the forces? Well, again, they're working against each other. So again, it's going to be a subtraction. So 150 newtons minus 100, it's 50 newtons to the right, because it's moving to the right of the red man who is stronger. So if we wrote this as a math equation, it says, how is this math equation? Oops. I don't want to do that, sorry. The math equation would be 150 newtons minus 100 newtons equals 50 newtons. Are the forces balanced or unbalanced? There's movement. That's right, they are unbalanced. It is moving. Okay, what happens to the speed of the cart when one side is winning tug of war? Well, the speed changes. It goes from being 0 to a value. It's starting to move. Is this type of motion considered acceleration? Well, acceleration is any change in motion. When something starts moving, when something stops moving, if it turns, if it slows down, or if it speeds up. Is this acceleration? Yes, it is acceleration because it is a change in motion. What happens when the speed of the cart, when the tug of war is a tie? Well, let's go back and look at that. Let's try that out. Let's make it a tie again. Let's put an equal number of red guys of the same size on both sides and hit go. Did you remember what happened? Yeah, there's no movement there. What happens to the speed of the cart? It doesn't move. It stays the same. Oh. So is this considered acceleration? Think about what we know about acceleration. Starting moving, stopping moving, turning, slowing down, speeding up. Is this acceleration? No. There is no change in motion. Okay, so let's finish this up. When 2 small figures are both pulling in the same direction, their individual forces are blank together. So let's take 2 of our small figures and have them pull together. Look at that. So that's going to be adding the forces together. Because they're working together, we're going to add their strength. When 2 small figures are pulling in the opposite direction, then we are subtracting. An unbalanced force results when the sum of all the forces is, do you know the word? Unequal. and causes the object to move. A balance force results when the sum of the forces is equal and it causes the object to not move. So hopefully you're starting to understand, and this is a really good visual. Tug of war is always a good visual to understand this. We're going to continue to talk about it next week as well, and you'll get some practice actually adding and subtracting forces to figure out if it's balanced or unbalanced. But hopefully this helps you. Feel free to play around with this some more to see different sides, and you can add different values and start to predict if you can figure out if it's balanced or unbalanced. All right, so the last thing you're going to want to do is save this document. So File, Save As. You can keep the title the same. I'm just going to add a little 2 here. And you could save it wherever you want. I'm going to save it on my desktop. And then you can email that assignment to me. You can send it in the inbox. You could take a picture of it and upload the picture, or you could just upload that document into Canvas. I hope you've had a great week learning about forces, balanced and unbalanced. Have a great weekend. Bye.